All right, so postulate 18, slopes of perpendicular lines in a coordinate plane. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are perpendicular. So if we know it's a vertical line and a horizontal line, then we automatically know that they're perpendicular. Otherwise, we can take the slopes, and if we multiply the two slopes together and get -1 as the product, then that would tell us the lines are perpendicular as well, which the reason that we can multiply them together and get -1 is that perpendicular lines, the slopes are going to be negative reciprocals of each other. So in other words, you flip the fraction and change the sign to get the slope of the perpendicular line. All right, so starting off here, find each slope, then find the product of the slopes. Right, so starting off, we've got one line that has the points -3, 0, and 1, -2. I'm going to use the slope formula just like we did yesterday, y2 minus y1 over x2 minus x1. So our slope of the first line is going to be -2 minus 0 over 1 minus -3. It'll be -2 over double negative, so we add the 3's. -2 over 4, or -1/2. So the first line is -1/2. The other line has points 0, 3, and -3, -3. So the slope of the second line is going to be -3 minus 3 over -3 minus 0. Should give us -6 over -3, which will simplify to +2. Or if we want it as a fraction, 2 over 1. And then it says to find the product of the slopes. So if I take the two slopes, -1/2, multiply it times 2 over 1. It's going to give me -2 over 2, or -1. So since the product is -1, what's that tell us about the two lines? Right. Those two lines are going to be perpendicular lines, right? Since the product of their slopes is -1. Questions there? Anybody? All right. So moving on, decide whether line PQ and line RS are perpendicular. So basically, we're going to do the same thing we just did in the last one. Find the slopes, multiply the slopes. If we get -1 for our product, then we know that they're perpendicular. All right, so we've got line PQ, which is the points -3, 3, and 5, 2. So the slope of PQ is going to be 2 minus 3 over 5 minus -3, which would be -1 over double negative, so we add the 3, 8. So -1/8 is the slope of PQ. And then for RS, We've got the points 0, 1, and -1, -4. So the slope of RS is going to be -4 minus 1 over -1 minus 0, or -5 over -1, or +5 over 1 since they're both negatives in the fraction. So really and truly at this point we ought to be able to tell that they're not perpendicular, but we can go ahead and multiply them. -1/8 times 5 over 1, it's going to be -5/8, which is not equal to -1. And so since it's not equal to -1, we know that the lines are not perpendicular. Alright, so next thing up, decide whether the lines are perpendicular. We got line A has the equation y equals -2/3 x minus 1. Line B, y equals -3/2 x plus 1. So these are in y equals mx plus b format, where the m is the slope. So since they're already in this format, all we have to do is look at the equation in front of the x and get the slope for each one. So the slope of A is going to be the -2/3 coming out from right there in front of the x. And then the slope of B is going to be right here in front of this x, -3/2. Which if I multiply those together, -2/3 times -3/2, it's going to give me +6/6 or +1, which is close to what we're looking for lines to be perpendicular. But in order for them to be perpendicular, the product has to be -1, not +1. And so these two lines are not perpendicular. Alright, so then this next one is a little more complicated, because if we look at the equations that they give us for line E and line F, they are in standard form instead of being in y equals mx plus b format, or slope-intercept form. So we've got to first solve these equations for y so that they'll end up being in slope-intercept form. So for line E, -2x plus 7y equals -4. We got to get it in y equals format, so we'll start moving everything over, add the 2x. So to give us 7y equals 2x minus 4. And divide by the 7. So to give us y equals 2/7 x minus 4/7. So now from the equation, we can get the slope of E, of line E, is 2/7. And we do the same thing for line F. So 7x plus 2y equals 10. So subtract the 7x. 2y equals negative 7x plus 10. Divided by 2. That's going to give us y equals negative 7/2 x plus 5. So the slope of f is negative 7/2. And if we multiply those, 2/7 times negative 7/2, it's going to equal negative 14/14. Negative 14/14 is going to be negative 1. So yes, they are perpendicular. Alright, so line G has the equation y equals 3x minus 2. Find the equation of line H that passes through 3, 4 and is perpendicular to G. So from the equation here, we know that that number in front of the x is the slope for line G. So the slope of G is 3. And we need the slope of H so that we can come up with the equation for H. And the thing about the slopes of perpendicular lines is that they are negative reciprocals of each other. So if we look at 3 as being 3/1, the reciprocal of that would be 1/3. And we need to change the sign so it was positive, so our slope of H needs to be negative 1/3. So that gives us a slope. Then we can use the point 3, 4 as our x and y, so we can solve for the y-intercept. So using that y equals mx plus b format, plug in everything that we've got. So our y is going to be 4, our slope negative 1/3, our x value is 3, and plus b. So it'll be 4 equals negative 1/3 times 3 is negative 1, plus b, add the 1 to both sides, and we're going to end up with our b value equal to 5. So now we've got our b value and our slope that we're going to use to make our equation. It's end up in y equals mx plus b. So y equals m, which is negative 1/3, times x plus b, which is the 5. All right, and then one more here. The equation y equals 5/3 x minus 4 represents a mirror. A ray of light hits the mirror at the point 3, 1. What is the equation of the line P that is perpendicular to the mirror at this point? So, a lot of extra words, but really all it's saying is we've got a line that has the equation 5/3 x minus 4, and we've got a line that's perpendicular to that that goes through the point 3, 1. What's the equation of that line? Right. So the equation of the line that we're given is, or the slope of the line we're given is going to be 5/3. So So the slope of the mirror, that's what that equation represents, is going to be 5/3. And we need the slope of the ray of light. Slope of the ray. It's going to be the negative reciprocal of that. So we're going to flip the fraction and change the sign. So it's positive, so we need it to be -3/5. And then we've got the point 3, 1. So from here we can plug those into y equals mx plus b. So our y value from that point is 1. Our slope -3/5. Our x value is 3. And then plus b. So 1 is going to equal -9/5 plus the b value. And then we're going to add the 9/5 to both sides to get b by itself, which 1 in terms of fifths would be the same thing as 5/5, right? So 5/5 plus 9/5 will be 14/5 to be our b value. And now we take the b value and the slope. So our slope of -3/5 and our b value of 14/5, plugging them into y equals mx plus b. We get y equals m, which is -3/5, times x plus b, which is 14/5. And that completes the notes for 3.7.